So I have sent you an additional worksheet also on projectile motion. Also, we will discuss some questions from H.C. Verma also in the course of this lecture. So we were looking at projectile motion from an elevated point in the previous lecture, and we had seen the case of horizontally projected situation from an elevated point. So let's take it from that point onwards today.
Sir,
Yes.
so from major test 4 till where is it coming from
Till
kinematics?
projectile motion, till kinematics in 2 dimensions and 3 dimensions.
So 3 dimensions will be taught.
The general idea, the definitions have been taught for 3 dimensions. Okay.
So
How to velocity, acceleration, etc. All these things have been taught now in 3 dimensions.
yes, sir.
It's
So
done already. Only that much. But projectile motion complete. Okay. So what we are discussing today is also part of.
okay, sir. So next class will not be coming.
Next lecture, we will be doing some revision questions also, and we'll be starting relative motion if doubts and all are completed by then. Okay. So relative motion will not be coming in the project in the major test.
Okay, sir.
So up to this projectile motion concept. Okay. Right. So we were looking at projection from an elevated point. So last time the case we had seen was horizontal projection from an elevated point. Today we will see if the projection is oblique. Just a moment, people. Right. So projection from an elevated point. So the case we saw last time was horizontal projection. So this is the ground level below, and project something from a height h above. But if we project it horizontally, then we saw that it lands at a certain distance below. So this projection velocity is u horizontally. So we saw that by the time it lands here, you can see that taking our x and y axis like this, you can see that if this is at t equal to 0, then at any general time t, the velocity vector becomes u I cap minus, or in this case plus gt j cap, because I'm taking the y axis downwards. The displacement becomes therefore ut I cap plus half gt square j cap. And therefore, if it lands here at time t, then that time capital T becomes square root of 2h by g. And the final impact velocity Right? It has Vf because it's the final velocity. So that becomes ui cap plus square root of 2gh j cap. Okay. And also this range, that becomes u into capital T. So the range becomes u times square root of 2h by g. So these were the applications that we saw in the last lecture. You need not write this down because this is a recap of what we discussed. Now, today we will discuss the next case, okay, which is oblique projection. This is horizontal projection from an elevated point. Now, today we'll discuss this situation. What if there is oblique projection? That means it's projected at an angle. So now what we are doing is from such a point here, we are projecting an object at time t equal to 0 with a velocity u, but that is making an angle theta with respect to the horizontal such that it has a vertically upward component. Then the particle will have this kind of a trajectory. Eventually it will come and hit the ground. So once again, we want to find all these things: impact, speed, time, range. Okay. So given we know u, we know theta, or at least we know the magnitude of u, we know theta, we know h, and of course we know g. We want to find these various things. Displacement and velocity, instantaneous. In this case, since the projectile is first going up, okay, so it makes sense to take this as our x-axis, but take the y-axis like this, vertically upwards.
Sir,
Yes.
but in this case also accelerated due to gravity acts down. So we can
Yeah.
take
Yeah, but initial velocity has an upward component. So as I told you, there is no hard and fast rule, but it makes more convenience to take so that your u sine theta comes with a positive sign. Okay. So the initial velocity vector will be written as u cos theta I cap plus u sine theta j cap, and the j cap is now upwards. Okay, whereas your acceleration in this case will be written with a minus sign. So when you divide this into components, you can see that ux is u cos theta, ax is 0, uy is u sine theta, but ay is equal to minus g. So this is again uniform. Okay. So use these parameters to describe these things: time of flight, impact velocity, range, displacement, and velocity as functions of time. Just try this out, then we'll discuss an example. So let's take an example of numerical values above. Suppose u is 25 meters per second and this theta is 53 degrees. Okay. H is 45 meters and G is 10 meters per second. So see this UX becomes 25 cos, cos 53. So that becomes 15 meters per second. UY becomes 25 sine 53. So that's 4 by 5 into UY. So that's 20 meters per second. This is minus 10 meters per second square. So now at some general time t, and let's say the particle is here, has some general velocity v and some position x like this. Vx will be the same as u cos theta, which in this case will remain 15 meters per second. But Vy would have become u sine theta minus gt, or in this case, this is our Vy as a function of time. Okay. Likewise, x will become u cos theta t. So velocity as a function is like this. Okay. And x and y coordinates are above. So that is one thing done now. Now next is we want to find the time, the range, and the impact speed. So for that, yes.
Sir, why should we use sin theta t, right? Use sin theta t minus half gt square.
Yeah, u sine theta t. That's correct. Okay, so now refer to the diagram and the values given to find the time capital T and the range R.
Sir,
Yes, tell me.
sir, I am getting two values of time.
But one is negative, na beta? You'll get two roots of the quadratic equation, but one will be negative. So that one you will have to reject, no? Time can be positive only. Understood, no?
Yes, sir.
Okay, so you can see from just refer to the diagram and you will understand. At t equal to capital T, this time the y coordinate will be minus h because it's downwards, no? And our y-axis is upwards. So minus h should be equal to 20, or in general, u sine theta t minus half gt square. So substituting the values, minus 45 should be equal to 20t minus 5t square. So if we make this, okay. So other roots you are getting.
So it's 4 plus minus 2 root 13 by 2.
Okay. Okay. So you'll see that we'll have to take the plus sign. Okay, because 2 minus root 13 is a negative quantity, so we'll reject it. Okay. It will be nearly 3 point something like this.
Sir,
Yes.
sir, at time t is equal to how did you get this y is equal to negative h?
Look at the diagram above, you'll understand. You're taking the y-axis upwards, and the origin is at this point. Got it?
Yes.
Understood? But
Yes.
okay.
Distance is also covered in the negative y-axis, right? During the time of motion.
Yes, yes,
Sir,
yes.
sir, and the time should be some 5 point something, right? Because it's root 13.
Nee, root 13 is 1 point something. Sorry, root 13 is my mistake. 3
Sir,
point something. Yes, yes.
sir, but the height it covers after it covers the maximum height, it descends and comes back to the original height. Then it again descends, right? So
Yes.
how is it minus h at t?
But this is the starting point, okay, and this is where it is at t equal to capital T. So tell me, compared to this point, what is the y coordinate of this point? Is it negative or is it positive?
At tan t is equal to t is negative.
So that's it now. Okay. So the displacement now from here to here is this vector now. So the x coordinate is r. But what about the y coordinate? It's minus h, no?
Okay, sir. I got it.
What you understand?
Yes.
Hmm.
So the height which are given is the height of the platform, not the maximum height reached by the projectile.
No, why will that be given, beta? What will be given in the question is the height of the platform, no? From which
Okay, okay, sir. I got it.
yeah, so we have to add the 2 here. So it's about it's nearly 3.6 plus 2, so 5.6 seconds. If we approximate or round off up to first place of decimal, it will be like this. Anyhow, so this is okay for this. Now you can see that the range for r, what we have to do is at t equal to capital T, the x coordinate is equal to r. So that means range is u cos theta into this time. So it's around 80, 84 meters. Okay. And now the final velocity will be like this. It will be u cos theta I cap plus u sin theta minus gt j cap. So it's 15 I cap plus 20 minus 10 into 5.6. So it obviously has a negative y component, but that negative y component is 36. So this is the impact velocity. Okay, so hope this question is clear to all of you. Now let's move on to another example. Now in the next example, we'll see it's an oblique velocity, but it's an oblique projection, but such that, see, there's a downward component like this. So we are projecting at a projection speed of 40 meters per second this time, such that this angle with the horizontal theta is 30 degrees, and this height is given to us as 60 meters this time. So assuming that it will, okay, I'll give you some time to finish writing the previous example, then we can come back to this question.
Sir,
Yes.
sir, we'll also be marking some problems in the module to do.
Sorry, come again.
So will you also be marking some problems in the module?
Yeah, module, you can do the questions now of projectile motion along with the straight line motion. Huh? Like
Yes.
after today's lecture, you can do the entire module, because that is up to the relative motion is there in a different section, right?
Yes, sir. So which exercise we can do? 4 exercises, I guess.
Yeah, you should do all the exercises.
So which exercise has relative motion, which you could leave for now?
Relative motion is in a different section, better. So the kinematic section, which is there, you can do all the questions.
So in kinematics one, there is relative motion. No?
It's a very simple part, so you can try and attempt those questions yourself.
Okay, sir.
Okay, so hope you're finished with this question. Now moving on to this example. So we'll take G as 10 only. In this again, I want you to find all these things. Okay, so let's work out the solution of this question. Now, in this example, what I'll do is I'll take the y-axis downwards because the object is going down straight away. Initial velocity has a downward component. Okay. So taking x-axis like this and y-axis like this, you'll see that the initial velocity so these are the values. Okay. Now at t equal to capital T, what is the y coordinate? It's going to be 60. It is h. Okay. So the time of flight from here will come out to be 2 seconds. For range,
So it should be 6 seconds, no?
see the roots of that equation. Product of the roots is minus 12 and sum of the roots is, is 12 and sum of the roots is
Yeah, okay, so I'll check my calculator.
minus 4 now. Okay, now the final velocity you can see is like this. So it is No, but in this case, I've taken the y-axis downwards, na, Rohan. You understanding? I've taken the y-axis downwards. So we will write the y coordinate at this point as plus h, no, not minus h. Okay, so people hope this question is fully clear. Okay, now we'll do some more example questions of projectile motion. So we'll start with an example that is based on this projection from a height concept only. So there are two buildings like this. Building A is of height 100 meters. And building B is of height 45 meters. Also, the gap between the two here is given as 50 meters. Okay. Now, what we are doing is we are projecting a particle horizontally from here at t equal to 0. So we want that it should come and land on B. So find the minimum value so that the projectile lands on B. Take GS10 again. Just try this out, people. This is a horizontal projection.
So it should land at this just the starting point of B.
Yeah, the minimum will correspond to that. Okay. I mean, if we give velocity less than the minimum value, then it will end up, missing that corner point, that left-hand corner of B, and land on the ground somewhere between A and B. So we don't want that. Okay. Or it might go and impact the side wall of B. We don't want that. It should land on top of the building B. So what is the minimum speed you required for that?
Okay.
Okay, so far one person has got the answer, Kirti. Let's check it out. Okay. So what we can do here is, once again, we can take our y-axis downwards and our x-axis horizontal. So when it lands here at some time capital T, you can see, so in general, x will be ut and y will be half gt square or
Sir,
5t square. Yes.
so in the chat I've written U is getting autocorrected to YOU. That's why I wanted to just.
Okay, that's okay. Yeah, your answer also checked out. Okay. So now you can see that at t equal to capital T, what should be the value of y? It should be HA minus HB, right? So it should be 55 meters. So you have, okay, so that is approximately again
3 point something.
3.4,
3.3.
3.3 or 3 point, okay.
Sir, taking 3.3 afterwards, it makes the calculation a little easier. That's why I took 3.3.
Okay.
Sir, or you can square x square, square that x square is equal to u square t square, and then put t square is 11.
It's the same thing, na? So you'll have to take square root of something else again, na? As x is, okay. So anyway, so t is this root 11, which if you approximate up to first place of decimal, it is 3.3. Okay. So now what is happening at this time t, your x coordinate should be greater than equal to 50 meters. Okay. So ut should be greater than equal to 50 meters. Okay. So u should be greater than equal to 50 by t. That means the minimum value of u that is possible for us is 50 by t, or in this case 50 by root 11. So you can always write that as 50 into root 11 by 11 and solve it that way. Anyhow, so in this case, we'll take the approximate value. So it will come close to about 15.2 meters per second. Okay. So anyhow, as long as that logic is clear, it's fine.
So answer is correct.
Yes, your answer is correct. Very good.
So 15 meter per second is also fine.
Yeah, I mean, if you are rounding off up to units place, then the answer is 15 meters per second.
Yes, I did some approximate calculations.
Yeah. Okay, anyhow, so hope this is clear, this question. Okay, now let's look at,
So
yes.
for projection from a height, is there any equation for the trajectory or something?
Projection from a height, equation of trajectory can be written because you know x and y as function of time. Na? So you can do it same way by eliminating time. You understanding?
Yes.
So, but in this case, we don't know the u to begin with. Na? So writing the equation of trajectory will not be of so much use to us. It's better to go by this method. Okay.
Yes, sir.
Okay, next example. You will see a sort of reverse of this situation, that we are projecting from the ground level, but the object has to land at a height. let's take this case. So we are projecting, let's say, at 50 meters per second at an angle of 53 degrees to the horizontal like this at t equal to 0. And happens is something goes and lands like this, because it is given to us that this distance is, once again we'll take g as 10. So this distance is 200 meters. Okay. And this height is 60 meters. So if it is projected at time t equal to 0, you have to find the time at which the impact happens here. Okay. And we have to find this distance d. And the impact speed. Do one thing, take this height instead of this much, take it as 20 meters. Okay. Okay, so very good. Now this is a problem where we can actually make use of equation of trajectory also. Okay, but I'll show it by the normal method first. So if you take this as y-axis and this as x-axis, then at any time t, the x and y coordinates are such that x is here going to be, I'm just directly writing it, okay, 30t, and y is going to be 40t minus 5t square. Just verify equation 1 and 2, all of you first, okay? And the equation of trajectory will become y is equal to 4 by 3x into 1 minus x upon 240. This is the equation of trajectory. Okay. So at the point of impact, suppose the x coordinate, which is basically 200 plus d, is some x1, and the y coordinate is 20. So you can substitute that here. You can see that so we'll get this kind of quadratic equation.
Sir,
Yes,
sir, can you tell that how did 240 come?
that standard equation of trajectory, y is equal to
There should be 200. Okay, sir, I got it.
x tan theta. So tan theta here is tan 53 or 4 by 3, and r is whichever way you calculate it, you'll see you'll get it to be 240. Okay. So this equation now it can be written as, just transfer the 3 by 4 this side. So 15 is equal to x1 minus x1 square by 240. Okay. So my x1 will come out to be so in yes, okay. So I can take 60 into 2 actually common. Now we can see that since x1 is 200 plus d, so x1 must be greater than 200. Therefore, x1, I guess this, or approximately like this. Okay. So it will come very close to 224 meters, 223.8 meters. So from that you can see that D is approximately 23.8 meters. Okay, so this is one very efficient way of doing this question using equation of trajectory. Otherwise, you can use the time-based equations also, and I'll leave that part of the solution to you. Okay, now what else we wanted to calculate it? We wanted to find the time. So impact occurs at t equal to, let's say t, when x coordinate becomes, okay, so about 7.5 seconds close to. Okay. And from that you can find the impact velocity also. And then you can take mod of that, that will give you the impact speed. So these are some slightly more tricky and typical type of questions from projectile motion, which are, let's say, JEE Advanced level. Okay, people, so hope this is clear. Now let's move on to the last part of projectile motion, which is, I mean, again, nothing new in terms of equations and all, but another way to deal with projectile motion when we have projection on an inclined plane. Okay, so instead of throwing the object from a horizontal surface, we are doing something like this. Now again, there are two cases possible here, so we'll discuss both of them. So either, we can throw it from somewhere at a lower position on an inclined plane so that it's going and hitting an upper type of position. So we could have this situation, so that the path of the projectile is like this. Okay. Or we could have this kind of a situation. Let's say the path of the projectile is, let's say, like this. Okay. So in both cases, you can see that the inclined surface is at alpha with respect to the horizontal, and the initial velocity u is at the projection velocity is at an angle beta, but not with respect to horizontal, but with respect to the inclined plane. So again, we want to find out, let's say it goes and lands over here. So the range with respect to the inclined surface, okay, the time at which it lands, all these kind of things we want to find out. So in both cases, what we will do is that we will take our reference frame will be taken such that the x-axis is along the inclined plane, and y-axis is normal or perpendicular to the inclined plane, like you do in Newton's laws of motion. Whenever you're making a free body diagram of an object on an inclined plane, you take your components of the forces, or you resolve the forces according to an xy system which is like this, not an xy system which is vertical and horizontal. That way it works out more conveniently. So we'll do the same over here.
Sir,
Yes.
sir, if we take it horizontally and vertically also, we can do it. We can take that point where it reaches as the height, like x and y coordinates.
Yeah, but it'll become a little more complicated. Okay, so it's easier to do it this way. Okay, that is why in the standard derivation we take horizontal and vertical. I mean, we take x and y as along the inclined surface and perpendicular. Especially to find something like capital R or the time, etc., capital T, is going to be much easier by taking this kind of situation. Okay, so let's solve with a couple of examples. We'll take a situation where we have case 1 and u is, let us say, 28 meters per second, alpha is 45 degrees, beta is 37 degrees, g is 10 meters per second square, and we are going to take root 2's value as 1.4. It's given. Okay, so we want to find all these things. So try to set up the coordinate frame yourself. We will discuss. Okay, so what I want you to do is follow the instruction for the reference frame as I've given. Okay, and first of all, express u in component form and acceleration in component form. Do this. Then you can write x and y as functions of time. So that will be the next step, okay, from here to here. And then from that, we will solve for all these things. Okay. So first of all, take the reference frame. And then define U, A, and all this. Remember, the acceleration will be G, vertically downwards. But now because you're taking X and Y axis as inclined like that, so we'll have to resolve G also into two components, which you're used to doing. It's nothing new, it's from Newton's laws.
Sir,
Yes.
sir, in this case, the velocity along x-axis will also decrease, right?
Yes, very good. There will be a deceleration for both Vx as well as Vy will also have a negative acceleration because you're projecting up the inclined plane. That's correct. Okay. So let's look at this in more detail. So this is my inclined plane, which is at 45 degrees. Okay. And now I'm projecting my particle somewhere here, let's say. So as discussed, the first thing is we'll take the x-axis. In this case, up the inclined plane because it's going to move in that sort of direction. We'll take the y-axis normal to the inclined plane like this. Okay. So my initial velocity vector, it will get resolved like this: u cos beta I cap plus u sin beta j cap. Okay. So the x component of initial velocity in this case will become 28 into actually let's take a different value. It will just be easier. Just change this to 35. Unnecessarily, I don't want decimal places. So just make a correction in the question. Make the initial speed 35. Okay. So 35 into 4 by 5. How much that will give us?
28 meter per second.
Yeah. Okay. So 28 will be this one. And the y component will be u sin beta. So 35 into 3 by 5. So that will become 21. meters per second. This is going to be easier to handle. Okay. Now, as the particle is moving, what about the acceleration due to gravity? It's always a vector pointing like this. So when we resolve this vector, it will have components which are both negative along the x-axis and negative along the y-axis. Okay. And you are used to this from Newton's laws that if your axis is making an angle alpha with the horizontal, the inclined surface, then this angle here will also be alpha. So when we resolve our acceleration, it will have components minus g sine alpha I cap minus g cos alpha j cap. So acceleration's x component will become minus 10 by root 2. That is minus 5 root 2. So that will take as 7. Okay. Because the question has asked us to take root 2 as 1.4. Whereas the y component of acceleration remember alpha is 45 degrees. Okay. So the y component of acceleration is also minus 7. Okay. So we have all this important data. So now at any general time t, we can see that so velocity's x component will be given by 28 minus 70. Similarly, velocity's y component is 21 minus 70. The instantaneous velocity is this in component form. Okay. And the x coordinate will be given by ut plus half at square. Okay. So 21t minus 7 by 2 t square. So these equations become very important. Okay. Now the rest of the method is the same. Now whenever it goes and impacts on the surface, at this point the x coordinate is r, the y coordinate is 0, the time is capital T, and the velocity is this. Okay. So we'll use all this stuff here that at t equal to capital T, y coordinate should be 0, x coordinate is r. This is the impact velocity. Okay, so just work this out quickly.
So we have to find our maximum height and time of flight, right?
These three things you have to find. Capital T, okay. We have to find capital T, time, the range on the inclined surface, and impact velocity.
Okay, sir.
Okay, people, so let's finish off this calculation quickly. Yeah, I think you will get whole values if you just take that root 2 as 1.4. Should not be too difficult. Okay, so you can see that when you solve this thing, that y is equal to 0, so you are having time as 21t minus 7 by 2 t square is equal to 0. So you'll get the time as 6 seconds. So 6 seconds is the total time. Okay. So now the thing is that x is range at that time. So range will become the value of x at t equal to capital T. So from the first equation, you can see that 28 into 6 minus 7 by 2 into 6 square. So it's 28 into 6 minus, this will become how much now? 7 by 2 into 36, right? So that is 22 into 9 by 2, isn't it? I mean 28 into, you write it like this. Okay. Range is this. Okay. So hope the calculation part is clear, people. Okay. We have just made use of this equation. Yeah. Along with this fact. And now we'll just substitute the time of 6 seconds in Vx and Vy. So we'll get the impact velocity. Okay, so for the impact velocity, now you can see Vx was 28 minus 70. So at t equal to 6 seconds, oh, sorry, 28 minus 42, so minus 14. Okay. Now it's easy to understand why the x component of impact velocity will be negative, because it's going and hitting like this. So the impact velocity will be like this. So compared to our x-axis and y-axis, it's having a negative x component and a negative y component. This angle here is greater than 90 degrees. That's why okay, people. So with this, we complete the theory part of projectile motion. We'll see examples in the next lecture of the second case of this projection from an inclined surface, where we project from a higher point also. But the method is again the same. You take x and y axis as along the inclined plane and perpendicular to the inclined plane, resolve your vectors accordingly, and then just apply the simple equations. So nothing too complicated about this. So next lecture, we'll do some more problems in projectile motion, some revision questions, doubts, etc. also. So you're well prepared for the major test on 11th. Okay. So that's it from my side, people, for today. Wish you all the best. Have a nice day.
Thank you, sir.
Thank you, sir.
Sir.
Yes,
Sir,
beta. Yes.
sir, in the worksheet, there are angles like 26 degree and 49 degree.
A couple of places, just use a calculator. No? I mean, just use a digital calculator which has scientific calculator, or you can, if you have the trigonometric books, sine cos tables, you can use those also. Okay.
Okay, sir. Thank you, sir.
Okay.